regarding sa ating vapor compression cycle, di ba? So let me read first. A simple vapor compression cycle develops 15 tons of refrigeration using ammonia as refrigerant and operating temperature of 24 degrees Celsius and evaporating temperature of negative 18 degrees Celsius, and assuming compression are isentropic and the gas leaving the condenser is saturated, find the power per ton. So naghahanap lang ng power per ton. So at given tayo ng properties of ammonia, meron kang enthalpies, HF, H2, Hg. So before we solve this, we needed to recall yung pH diagram natin since this is a vapor compression cycle. So para hindi nyo nakabisado yung formula, always remember na kapag refrigeration, same with the power cycle, pwede nyo siyang ma-derive from the diagram. So sa refrigeration system, pag vapor compression, kadalasan pH diagram yung ginagamit. So drawing mo na yung saturation curve, then recall the simple vapor compression drawing. So meron kang 0.1 dito, so may saturated curve sa kanan, nanangat siya para sa compressor, 0.2, condenser, 2.3, hanggang dun sa may saturated point sa kaliwa, then 0.4. So from that, we can now have yung ating mga kailangan na formulas. Sige, so ang hinahanap sa problem is power per ton. That's basically work ng compressor over QE. So ano sir ang work ng compressor kapag vapor compression? So we can derive that, sabi ko nga sa diagram. So ang compressor dyan is ito. Itong nasa taas is condenser. And ito namang nasa kaliwa is what we call the expansion valve. Then sa ilalim yung evaporator natin. So since work ng compressor din to, we will look sa compressor. Yun yung point 1 to 2. So in terms of enthalpy, parang steam table or steam power plant, work ng compressor is 2 minus 1. So we will talk about enthalpies. That's H2 minus H1. Over QA. So ang QA natin nasa evaporator, yun, that is from points 4 to 1. So that's pinakakanan, that's H1 minus H4. So what we needed to do lang to solve this problem is to know what are those enthalpies. Sige, so etong point ko nasa kanan, di ba? Sa may evaporator. From the problem, ito evaporator mo, nasa kanan na saturated curve, that's Hg. Therefore, we know that H1 is yung Hg na yan. That's 1439.94 kilojoule per kilogram. Another thing is itong 0.3. Nung meron sir sa 0.3, kasi H2 basically is given ito yan. Sa 0.3, nasa kaliwa siya ng saturated curve. That's basically point N. And sabi nga natin 3 to 4 dahil isenthalpic yan sa expansion valve, equal lang sila. So H4 is H3, which is equivalent to HF at 24 degrees Celsius. That is 312.87 kilojoule per kilogram. So now, meron ka ng H4, H3, H1, H2. Ayun yung mga kailangan mo dito. We can substitute it dun sa formula natin. Ilagay lang natin yung values. H2 is 1665 minus H1 1439.94 over H1 1439.94 minus H4 na 312.87. Sige, so hindi ko na nilagay yung unit na kilojoule per kilogram because those will cancel out. At in the choices, we need a unit of kilowatt per ton. So paano natin kukunin yung kilowatt per ton? So just recall yung conversion ng 1 tons of refrigeration sa kilowatts. So sa taas yung kilowatts kasi yun yung kailangan ng choices, and sa baba yung tons of refrigeration. So 1 tons of refrigeration is 3.52 kilowatts. Okay, so from that, okay na yung units. Pwede na natin makuha yung problem by simply substituting yung values. So 1665. So ilagay mo lang yung enthalpies natin. And pag nalagay na yung enthalpy, basically ang gagawin na lang i-convert, diba? So sa refrigeration system, lalo na kapag enthalpies yung mga kinukuha natin, problem at given na yan, hindi na kailangan ng table. That will basically simplify out yung problem natin. So makuha natin is 0.702 kilowatt per ton. So yan yung letter A natin.